topic. Kasi majority ng mga computations, mga problems, equations na involved sa EMAG or sa electromagnetics is vectors. Kaya important na malaman natin kung paano natin ina-analyze, sinosolve, or pina-process yung different vectors, vector quantity. Okay? Okay, so before tayo mag-proceed dun sa actual vector analysis topics, so alam ko familiar pa rin naman kayo dito, no? So review lang. Meron tayong two types of quantity. In physics, ito na-discuss din sa mechanics. So that is the scalars and the vectors or vector quantities. So yung difference between the two is that scalar, these are quantities whose value may be represented by a single real number. It can be positive or negative. So examples, height or temperature, kulang ng this, or speed. So these are scalar quantities. So for vector, these are quantity with both magnitude and direction. Okay, so example is force and velocity. So acceleration is also a vector quantity. Okay, so yung difference lang nila, basically yung scalar, so pinapakita niya lang yung magnitude. Okay, while for vector, aside from the magnitude, makikita mo din doon yung direction ng certain quantity na yan. So for force, halimbawa, malalaman mo kung ano yung direction ng force, kung siya ba is to the right or to the left or up or down. So even for the velocity. So so yung parehas na quantity na yan is ma-encounter natin sa EMAG. So scalar and vector quantity. So meron kasi mga quantity na scalar and may mga vector quantities din tayo na i-discuss sa EMAG. Okay, so our focus is on two-dimensional or three-dimensional space. Kasi yung vector, it can be represented in many dimension or multi-dimensional space. Pero yung focus natin dito is 2D or 3D. Okay, so siguro dun sa mga dati yung subject sa physics, halimbawa, or sa mechanics. So yung mga vector quantities is represented in two-dimensional lang. Tama, no? Kung nare-recall nyo pa. So halimbawa si force, it's either up, down, left, or right. So two-dimensional yan. X and Y plane lang. Yung kung paano mo siya i-represent or i-visualize. So dito sa EMAG, aside from the two-dimensional space, so kailangan ma-visualize nyo rin, ma-imagine nyo rin ano yung itsura ng vector in 3D. Okay, so yung kaya medyo complicated sa EMAG kasi kailangan magaling ka mag-imagine kung ano yung itsura ng certain vector na yon in 3-dimensional space. So this yung vector is usually represented by a directed ray. Katulad na sa figure, itong red na arrow. Okay? So yan. So usually represented by a directed ray. So meron kang starting point and end point. So yung end point mo yung arrow. So usually, yung vector, for notation, para tulad-tulad tayo, pag vector quantity is, may mga books kasi na para masabi mong vector quantity yon, naka-bold yung representation. Halimbawa, si A. So yung ibang books, naka-bold dyan, ibig sabihin vector yung A na yan, vector A. So yung hindi naka-bold, so scalar quantity. Yung ibang book din is may arrow sa taas. Halimbawa, hindi siya naka-bold pero may arrow sa taas. So this is vector. O kaya is A na maliit pero may arrow sa taas. So vector quantity yan. Meron din ibang book na naka-bold na at the same time. May arrow sa taas. So vector yan. Okay? So kayo malilito ha. Pag may nakita kayong arrow dun sa taas ng letter, so pinapakita lang nun na vector quantity yan. Okay, so any questions so far? Okay, so malinaw pa. Wala pa naman.
Parang malinaw naman po, sir.
Okay, so good. So, basta yung kasi minsan nagkakalito-lito sa notation. So, para standard tayo, so mahirap namang i-identify sa sulat lang kung naka-bold or hindi. So, lagyan nyo na lang ng arrow sa taas kung vector yan. Kasi hindi mo naman pwedeng ma-distinguish yung isang letter kung naka-bold yan or hindi kapag sulat lang. So, para tulad-tulad, so na may arrow dapat sa taas kapag vector quantity. Okay, so may arrow sa taas. Okay, so vector and scalar field. So ano ba yan? So pag sinabi nating field, it can be scalar or vector field. So this may be defined mathematically as some function of that vector which connects an arbitrary origin to a general point in space. So ano ibig sabihin nun? So a field may be defined mathematically as some function of that vector which connects an arbitrary origin to a general point in space. So halimbawa itong mga nandito sa illustration. So basically pag sinabi nating vector or scalar fields, so ito mga nandito sa yung mga images na yan. So these are scalar fields. No, kasi wala siyang direction. Walang pinapakitang direction. Wala ka rin makikita dyan mga arrows kung saan pupunta or saan galing. So these are scalar fields. So yung field kasi, yung tinatawag ni scalar fields. So basically, ano lang yan, mathematical function. Okay, so mathematical function lang siya. So huwag niyo masyadong intindihin yung formal definition niya. So tandaan niyo lang, pag sinabi nating field, this is some function, mathematical function. So for scalar field, input halimbawa natin is xyz. So it can be represented by a certain function xyz. Okay, so mamaya makikita kayo ng mga examples ng field, vector and scalar. So examples ng scalar field, no? So examples to, scalar field yan. So example is density at any point P within a volume. Okay, so halimbawa meron kang cylinder, no? Meron kang cylinder. Okay, so halimbawa meron kang cylinder. And then pinalat mo yung density at any point dun sa cylinder, dito sa cylinder na to. And then ito yung nakuha mong plot. Okay? So that is a plot or a scalar field of density at any point dun sa volume ng cylinder. So another example is elevation of a point xy from sea level or temperature at any point A inside a container. So that can be also a scalar field. For vector field, same definition yan. Vector lang yung quantity. Okay, so halimbawa, wind strength and direction in a region. So halimbawa, itong image na to. Okay, so this represents the wind strength and direction in a certain area or region. So naging vector field yan kasi yung wind strength mo, aside dun sa magnitude ng wind strength, meron ka ding direction. Okay, kung walang direction, scalar field yan. Pero since wind strength and direction, itong image na to, so this represent a vector field. So isa pa is yung magnetic field ng Earth. No? So from the north papunta south, yung magnetic field force, so that is also a vector field. Okay, so in vector, one operation involved dito is vector addition. Okay? So, paano ba tayo nag-a-add ng vector? So, vector addition follows the parallelogram law and is commutative and associative. So, kung natatandaan nyo pa, na-discuss ba sa inyo parallelogram law sa mechanics or sa physics? Or hindi? Okay, so halimbawa, ito no. Meron kang vector A. Okay, so this is vector A. And meron kang vector B. Okay, so kukunin mo yung ipag-a-add mo sila. So pwede mong isolve yun using parallelogram law, which is ipro-project mo yung isa, itong vector B dito sa taas, sa opposite side, and then yung vector A sa kabilang side. So yung diagonal dun sa parallelogram will represent the addition of A and B, vector A and B. Okay? So for subtraction, anong nangyayari lang dyan is tinatranspose mo yung direction ng isa. So halimbawa, dito sa figure natin na to. Di ba yung originally, yung vector B natin pakanan. Pero kung magma-minus ka ng B kay A, babaliktarin mo lang yung direction niya. So from papuntang kanan, magiging na siyang pakaliwa. And then same process, yung parallelogram law. Okay? So if two-dimensional, meron tayong mga, pwede natin gamitin yung calcu. Okay? Pag-add at pag-minus ng vector, if alam mo, gusto natin kunin yung resultant force. So, di ba sa physics or sa mechanics, dati pinapakuha sa atin na resultant na. Resultant force. So, para makuha yung resultant force, pwede mong gamitin lang yung calcu kahit hindi ka na mag-parallelogram law. So, ang tatype mo lang doon dapat naka-complex mode ka. O resultant vector kung hindi force. Ano ba? Resultant vector. So, gagamitin mo lang yung calcu. I-type mo lang halimbawa si A dito. Si A is 20. 20 yung magnitude niya. Si B is 10. And then to is, kailangan alam mo lang yung angle na to. Okay, so halimbawa yung angle na yung theta is 40 degrees. So para makuha yung resultant na A plus B, i-add mo lang siya using complex mode na calcu. So 20 angle 40 degrees plus 10 angle 0. So makukuha mo na yung value nung A plus B. Tinaro na to. Okay, so makukuha mo na yung value nung magnitude nung yung vector addition na yon. Kung subtraction naman, so palitan mo lang tong add na to, gawin mong minus. Okay, kasi di ba sabi nga dito, negating a vector reverses its direction. So that is also vector subtraction. Okay, so meron tayong two property under vector addition. First is the commutative property. So if we have two vector A and B, in-add natin siya, equal lang din yan sa B plus A. And associative is if meron tayong vector A plus quantity B plus C, that is also equal to A plus B quantity plus C. So these are two important property ng vector addition. Oops, nawala. Okay, so for multiplication, first is vector multiplied by a scalar. Okay, so paano ba mag-multiply ng scalar? Multiply mo siya sa vector. So this obeys the associative and distributive laws. So for example, si R plus S dito is scalar. Okay, so halimbawa, R plus S are scalar quantities. I-multiply mo siya sa vector. So ito is scalar na. So ito yung vector quantity mo. Okay? So yung vector multiplied by scalar, it obeys associative and distributed laws. Sino yan? Pag mag-join kayo gamitin yung email yung slsu.edu.ph. Okay, so if mag-join sa mga meeting natin, gamitin nyo yung email ng SLSU. Okay, so for this, parang algebra lang, simple algebra. So, distribute, multiply, multiplication lang nito ng binomial. So, R, multiply ng A plus B plus S, multiply by A plus B. Then, pwede mo i-distribute yung scalar sa loob ng parenthesis. And then, same with S kasi scalar quantity siya. So, ibang usapan kapag vector to vector. So, ito is applicable lang to kapag vector, minultiply mo sa scalar. So, final answer will be this one. Okay, so tandaan nyo, hindi ganyan yung process kapag multiplication ng vector to vector. So, may discuss natin kung paano pag vector to vector. So, a vector reverses its direction when multiplied by a negative scalar. Okay, so tandaan yan. So, kung halimbawa, ito yung direction ng vector mo, ito si vector B, pero yung vector B, minultiply mo ng negative 1, halimbawa. So, mababaliktad lang yung direction yan. Opposite. So, this will be your negative 1 times B. Okay, so, every time na multiply mo siya ng negative value, reverse lang yung direction yung vector. Okay, so dividing a vector by a scalar value is just multiplying it with the reciprocal of the scalar. Okay, so wala namang kailangan explain dyan. If i-divide natin sa vector ng scalar, so same lang siya ng... So same lang yung multiplication ng reciprocal ng scalar. So A multiplied by 1 over A. Okay? Any question?
Sasagot ako rotation.
Our call center.
Call center ba? Call center ba to?
Kanina na,
Question.
Ibig sabihin malakas ang yung ano?
Wala sa loob.
Wala pang question? Okay, so tuloy natin. So ngayon may mga examples tayo na para mas maintindihan niyo. Okay, so this is the Cartesian coordinate system. This is also known as the rectangular coordinate system. So, so kung mapapansin nyo dito, meron tayong dalawang figure na. So itong thumb, this represent the z-axis. Itong first finger is the x-axis. And then the second finger is the y-axis. So x, y, z. So in Cartesian coordinate system, meron tayong three axis, x, y, z. Na? Which is lahat yan perpendicular sa isa't isa. So ibig sabihin, 90 degrees to, 90 degrees, and then 90 degrees din yung nasa baba. Okay? So this is the Cartesian coordinate system. So di ba nasanay tayo? Ano lang, dalawang axis lang, no? X and Y axis. So ito is this is the y-axis, then this is the x-axis. So dito, in Cartesian coordinate system, meron tayong additional axis, the z-axis. So 3-dimensional na to. So ito kasing xy na to for 2D. So this one will be for 3D. Okay, so 3-dimensional. Okay, so for component vectors, so x-coordinate, so when we say component vectors, so ito yung component ng certain vectors. Kumbaga, yan yung bumubuo dun sa vector. Okay, so meron kasi tayong different components sa isang vector. So yung first is yung x-coordinate, which is equal to the distance of p from the yz plane. Okay, so x-coordinate is equal to the distance of p. So halimbawa, no, ito yung point p natin. Okay, so this is your point p. Yung x-coordinate is yung distance nung p from the yz plane. So alin yung yz plane natin dyan? So ito yung x, ito yung z, this is y. So yung yz plane mo will be this one. Okay, so that will be your yz plane. Or ito. Ayan. Yan, yung YZ plane natin. Yan. Yan yung YZ plane. Okay, so yung distance niyan dun sa point. Okay. So, yung Y coordinate is equal to the distance of P from the XZ plane. So, nasan si XZ plane? So, XZ plane is this one. Yan. So, this is your XZ plane. So, yan. Okay, so yung YZ plane, tama, yung YZ plane is, ito naman yan, yung kanina. And then yung Z coordinate is equal to the distance of P from the XY plane. Alin yung XY plane? Ito yung nakahiga dito sa ilalim. Yan. So yan yung XY plane. So yung distance na yan, that will be your Z coordinate. Okay? So a vector is identified by giving its three component vectors, which each lying along the three coordinate axes, whose vector sum is the given vector. So for example, this one. So vector R, ang component vector niya is si X, si Y, and si Z. Okay, so si vector R, merong tatlong component vector, yun yung si X, si Y, and si Z. Okay? So, para mabuo ang isang vector in Cartesian, meron kang 3 component vector X, Y, Z. Okay, so, any questions sa component vectors? Okay, so tuloy natin. For unit vectors, ito is tawag dito, special type ng vector in which yung magnitude niya is 1. Okay, so unit vectors are special type of vectors with unit magnitude or magnitude equal to 1. So pag kinuha mo yung magnitude ng vector na yun, equal lang sa 1. And directed along the coordinate axis in the direction of increasing coordinate values. So symbols is AX, AY, AZ. Or instead na naka-bold, pwede rin may arrow sa taas. AX, AY, AZ. Or ito pa yung isang representation ng unit vectors. So IJK yung gamit nila. Hindi ko lang kung na-encounter nyo na to. Kasi usually to ginagamit to sa physics or mechanics, IJK, to represent vectors. Marasigan, question. May question ka, ano? Marasigan? Nag-raise ng hand eh. Or napindot lang. May question ba, ano? Art? Hello? Wala?
Baka naipit na yung cellphone.
Nakatulog yun, ha? Gisingin nyo nga muna, ha? Tawagan nyo
Napindot
sa
daw, sir.
messenger.
Napindot lang daw po.
Napindot lang. Okay. So, tuloy natin. So, a vector pointing from the origin to a point P, which is my coordinates na x of 0, y 0, and z 0, is written as. So, ganito na tayo magsulat ng vector. So, halimbawa, si vector R. So, vector R can be written. Tapos, ang coordinates ng vector na yon is, so, or a vector pointing from the origin to a point P. Okay, so halimbawa, meron kang vector from the origin papunta dun sa point P. So, halimbawa, dito na. So, burahin natin to. So, halimbawa, meron ka daw vector simula dito sa origin, papunta dito kay point P. Okay, so yan. Itong vector na to. Itong red. So, may arrow dapat na vector. So, yung vector na yan, pwede mo yung isulat using this format. So, kung ang tawag natin dun sa vector is si R, tapos yung point na kung saan siya tumigil is si P, so R sub P is equal to, okay, so assuming na yung P, ang coordinates niya is x0, y0, z0, so ang pagsulat ng vector is ganito. So x0 multiplied by ax, arrow, plus y sub 0, AY plus Z0 AZ. Okay, so, or pwede rin tanggalin nyo na yung arrow doon. No? So, pwedeng R sub P. So, X0 AX plus Y0 AY plus Z0 AZ. Okay, so pwedeng yan yung pagsulat natin ng vector dito sa ECM03. Okay, so yung AX represent the direction. Then yung x sub 0, yun yung coordinates, x coordinate, y0, y coordinate, z0, z coordinate. So for example, yung p, ang value niya dito is 1, 2, and 3. So ang vector mo will be ax. So yung vector r will be ax plus 2ay plus 3az. So ito yung magiging representation mo ng vector r at point P or directed to point P. Okay, so ganyan tayo sumulat ng vector. So yung naka-multiply dun sa AX, AY, and AZ is yung coordinates ng point kung saan directed yung vector. So for this example, for halimbawa lang to 1, 2, 3 ang coordinates niya. So yung 1 is the x coordinate, yung y coordinate is 2, and then 3 is the z coordinate. So, ganito mo siya isusulat. Question? Question? Marasigan, question. Ising ka na ba?
Sir, gising naman po. Naglag
Ah,
lang po kanina.
gising ka ba? Akala ko nakakatulog ko eh.
Nawala lang po
Okay, so tuloy.
internet ko.
Okay, sige. Tuloy tayo.
Wala nang pong tanong.
Walang question. Sige. So, ganun pagsulat ng vector, kailangan alam mo yung coordinates. Then, yun yung magiging coefficients nung a sub x, a sub y, and a sub z. Okay, so halimbawa dito, no? So, for p na 2, negative 3, and 1, so halimbawa, mag-given daw ng point. Point p, which is ang coordinates niya is 2, negative 3, and positive 1. So, paano natin i-plot yan? So, sa pagpa-plot ng 2, negative 3, and 1, so kailangan sumulat ka, mag-drawing ka muna ng katulad nito. So, this will be your z-axis. This is y. And then, dito yung x-axis. Okay, so positive 2. Bilang ka lang doon. So, positive 2. 1. Masyado maliit. So, alam ba, this is 1. And then, dito yung positive 2. Okay, so this is 1, positive 2. And then, yung negative 3 is, ito positive y ito. No? So, negative 3 sa opposite side. So, 1, 2, hanggang dito 3. So, mali yung division ko. Negative 1, negative 2, negative 3. So, project mo lang yan. Project mo yun. So, yung intersection nila, yun yung nasa baba ng point na hinahanap natin. And then, yung pagtaas niya is kung ano yung value mo dito. Kung 1 yun, so taas ka ng isa. So, dapat ito is 1. Pag pinroject mo dito sa, ano na to, sa axis na to, or ito pala, that is 1. So, halimbawa, ito is 0.5. So, itong point na to dito, this will represent the 2, negative 3, 1. So, ulit na natin para mas malinaw kung paano mag-plot. Gawa tayo ng whiteboard. Nakikita niyo yung Jamboard? Whiteboard? Or hindi?
Hindi po naka...
Ano nakikita
Parang
niyo?
hindi pa po, sir.
Hindi pa.
Yung PowerPoint pa lang po yung key.
Sige, wait lang Ayan. Nakikita niyo na?
Apo.
Okay, so if magpala-plot tayo, halimbawa ito, no? So gawa ka muna ng Cartesian axis. Yung XYZ axis natin. So hindi tuwid, no? So isipin nyo lang tuwid. Okay, so this will be your z-axis. This is your y-axis. This is your x-axis. So ito is positive x. This is positive y. Positive z. Kung may negative z ka, so pababa yun. Kung may negative x ka, diretso yun. Dito yung negative x. Ito negative z. And then dito sa kaliwa, negative y. So if halimbawa given sa atin na points is yung kanina 2, negative 3, and 1. So paano mo yan i-plot? So i-plot mo muna yung 2. So bilang ka dito 1, 2. And then negative 3. So dito yung sa kabilang side. So 1, 2, 3. And then project mo sila. Okay, so project mo. So kung ito yung intersection nila, tapos ang value mo ng z-axis is 1, so taas ka lang ng isa. Kung ito yung 1, so itapat mo lang. So yan. Yan. So dito ngayon yung magiging point na 2, negative 3, and 1. Nakuha kung paano mag-plot? question kung paano mag-plot. So, kailangan may ruler kayo na para pantay talaga. So, itong point na to, ang pinapakita mo pa lang dito sa graph na to will be yung point 2, negative 3, and 1. So, what if sinabi niya na i-represent mo graphically yung vector directed at point 2, negative 3, 1. So, ang gagawin mo lang dyan, gumawa ka ng arrow from the origin. So, simula dito. Ano, palitan ng kulay dito. Ayun. So, simula sa origin, papunta dun sa point para ma-represent mo yung vector. And then, lagyan mo ng arrow. So, itong arrow na to, nire-represent niya na ngayon yung vector at point 2, negative 3, 1. So, pag isusulat mo na yung equation ng vector na yan, kung pangalanan natin siya ng vector R, so yung vector R will now be equal to 2ax minus 3ay plus az. So, itong equation na to, nare-represent niya ng arrow na kulay pula. Pero itong point na to, nare-represent niyan lang nung point na yon, itong point na to. So, itong R na may arrow sa taas, yan is vector. And meron siyang tatlong components. Okay? So, mga vector component niya is 2ax, isa, negative 3ay, and positive az. So, yan yung vector component. Yung scalar component will be yung 2, negative 3, and 1. Okay, so, balik tayo dito sa PowerPoint. Okay, so balik tayo dito sa PowerPoint, no? So, katulad na banggit ko kanina, yung 2, negative 3, and 1, so ito yung vector na nakuha natin. So, 2ax minus 3ay plus az. So, yung 2, negative 3, and 1, so itong 2, itong negative 3, and yung positive 1, so hindi na lang natin sinusulat yung 1, kasi understood na yun na may coefficient siya na 1 doon, are called component scalars or scalar component. Pero yung kapag sinabi sa'yo, pinahanap sa inyo is vector component, so ang sagot dapat doon is 2ax, 3ay, and az. So what if, ang given na vector is 2ax plus az? So ano yung natin dito? Ano yung scalar component? Anong scalar component dito? Volunteer. Ano sa tingin niyo yung scalar component? Delima.
102 po.
Ano? 1,
102.
102.
201 po pala. Baliktad.
Yan, 2, 0, 1. So ito yung magiging scalar component or component scalars. So ano ngayon yung vector component? Dilema ulit. Anong sagot? Saan ka na?
Sir.
Yan, anong magiging component vectors?
2ax.
2ax.
Si 0ay, di 0 po.
0.
Az.
Az. Okay? So, malinaw yun ha. So, yun yung magiging component vectors natin. Okay? So, yung mga sumasagot sa recitation, so sila yung may points sa recitation na grade. So, malaking part ng grade nyo will be recitation. Kaya make sure na nagpa-participate sa recitation na. Sino ngayon? Si Delima na. Okay? Question? Any question? Okay, so proceed tayo sa distance vectors. So ito is another type ng vector. So for example, meron tayong vector RPQ. This is a distance vector whose tail is at P and yung head niya or yung arrow is at Q. So, pwede nating makuha yung value niya. So, halimbawa, no, meron kang given ka ng dalawang points. Point P. So, ito is x1, y sub 1, z sub 1. Then, point Q, x sub 2, y sub 2, z sub 2. So, meron ka daw dalawang points. Then, pinahanap sa'yo, ano yung distance vector from P to Q? So, ang pinapahanap sa'yo doon will be R sub PQ, which is, pwede mo yung makuha using this formula. Ima-minus mo lang yung vector at point Q minus vector at point P. So, if ito yung value natin, itong dalawa, ano magiging ko dito, vector? Paano ko isusulat si vector at P? Paano ko isusulat si RP? If ang coordinates niya is x sub 1, y sub 1, z sub 1. Paano natin susulat? Volunteer. Raise hand lang yung sasagot. Paano natin susulat si vector R sub P? If ang coordinates is x1, y1, z1.
Sir, try.
Sige. Pagyo. Paano?
X sub 1 AX
X sub 1, AX,
plus
plus
Y sub 1 AY
AY,
plus 7
plus
ay Z
Z,
sub
Z,
1
Z sub 1,
Z sub 1 AZ.
AZ. Okay, so this will be your vector. Oops, nawala. Nangyari. Okay, so rewrite ko So, ang sagot ni So, ang pin natin x1, y1, z1. So, ang sagot niya is, x1 ax plus y1 ay plus
AY
z1 az.
Z1 AZ.
Okay, so tama yan. So, yan yung magiging vector RP. So, ito yun. Vector RP will be x1 ax plus y1 ay plus z1 az. For Q, if ito is x2, y2, and z2, so same process lang. So, this will be equal to x2 ax plus y2 ay plus z2 az. So, if pinahanap sa atin yung distance vector from P, so simula kay P, kasi yun yung natin, papunta kay Q, so ito yung hinahanap sa atin, R, PQ. Okay, so which is, pwede mong makuha, ima-minus mo si ito, kasi ito si RQ, ima-minus mo dun sa RP. So, paano yun? So, magiging value mo ngayon dito will be x2 minus x1 ax plus y2 minus y1 ay plus z2 minus z1 az. So this will be your distance vector from P to Q. So wag kayong malilito kasi una dito P tapos Q, pero pag nag-minus ka na, uunahin mo yung Q. Ang ima-minus mo sa kanya yung P. Question. Okay, so malinaw, ganyan pagkuha ng distance vector. So kailangan meron ka ngayong dalawang vector or dalawang point para makuha mo yung distance vectors doon sa dalawa. Okay, so example. Yan, so ito yung example, may values na tayo. So example daw, vector RP. Okay, so it is vector RP. May arrow dapat to sa taas na. Is 2ax minus 3ay plus az. So, pinahanap sa atin ngayon yung distance vector between point P and point Q. So, hahanapin lang natin si R, PQ. Okay? Which is, paano natin kukunin yan? So, RQ minus RP. So, RQ is negative 4ax, negative 4 minus 2. Copy mo, ax plus negative 1 minus negative 3. So, ay plus 2 minus 1 az. So, na magiging final answer? So, negative 4 minus 2, negative 6 ax. Negative 1 minus negative 3, ilan to? positive 2ay. Tama? Tama ba? Tama, mali.
Tama
Tama
po.
po.
Tama, no? So,
Tama po.
magpa-positive, no? And then, plus AZ. So, this will be your vector RPQ. Okay, so lagyan na lang arrow sa taas. Any question? Madali, mahirap? Mahirap na ba o madali pa? Ano to? So, madali pa, no? Okay, so another, so another topic under vector is yung tinatawag nating vector norm. So, ano ba yung vector norm? So, basically, vector norm is yung magnitude, no? So, for a vector B, which is equal to B sub x ax plus B sub y ay plus B sub z az. So, the magnitude B, so pag may nakita kayong ganitong symbol, B tapos, yan, pinapahanap lang sa atin yung magnitude. Okay? So, pag may parang dalawang absolute value na, so pinapahanap sa yung magnitude ng vector na yan. Kung ito yung vector B natin, so pwede nating masolve yung magnitude niya using the Euclidean norm. Euclidean norm. Using this formula. Square root of yung coefficient sa ax squared plus coefficient ni ay squared plus coefficient ni az squared. So, makukuha mo na yung magnitude or yung Euclidean norm. Okay, so simple lang naman yung formula. Okay, so kanina nabanggit natin yung unit vector na. So, which is yung unit vector. Ano nga ulit yung unit vector? Sino na nakakatanda? Babanggit ko lang kanina. Ano ang magnitude ng unit vector? Ano magnitude ng unit vector? Limot niya na.
1 po.
Ayan, sino yan? Sino nagsalita? Cortez?
Cortez po.
Ayan. So, magnitude natin for unit vector is 1. Okay, so kaya nga siya tawag na unit vector. So, merong unit magnitude. So, the unit vector in the direction of B or A sub B is given by this formula. So, para makuha yung unit vector, pag alam mo, pinahanap sa'yo, ano yung unit vector in the direction of vector B? So, pwede mo masolve yan using this formula. I-divide mo lang yung vector na yon ng magnitude niya, which is given by the Euclidean norm. Okay, so for example, hahanapin natin yung unit vector nito. So, i-divide mo lang yan ng magnitude niya. Okay, so example, ayan. So, example, given sa atin si vector H, ax plus 2ay minus 2az, hahanapin ang magnitude of vector H and its corresponding unit vector. So to get the magnitude, so ang unang ipinapahanap sa atin is magnitude ni H, which is given by the formula na yung coefficient, no? Coefficient ni ax. So anong coefficient ni ax dito? 1. So 1 squared plus coefficient ni ay is 2 squared or 2 squared lang natin, and then plus negative 2 squared. So ano magnitude ni vector H?
Square root of 5?
9.
9 ba?
3.
3.
Square root of
Okay. So 3. So 3 will be the magnitude of vector H. So sagot mo ngayon, may isa ka ng sagot dito, 3. So pag pinakuha sa unit vector ni H, ganito yung representation. Okay, so A sub H. Okay, so unit vector is represented by A sub H. So this is equal to H, yung vector, divide mo nung magnitude. Okay, so ibig sabihin, ang H natin is AX plus 2AY minus 2AZ. So divide by 3. So, sagot mo will be 1 over 3 AX plus 2 over 3 AY minus 2 over 3 AZ. So, this will be your unit vector directed along vector H or A sub H. Question. Tanong. So, malinaw So, ganyan yung pagkuha ng unit vector. Kailangan alam mo muna yung magnitude and then i-divide mo yung given vector by that magnitude. Okay, so break muna tayo 5 minutes. So mag-CR muna kayo. Mag-CR. 5 minutes na. Balik kayo ng 2:33.
Okay po.
May circuit pa.
Okay, so resume tayo. Uy. Bagyo, i-mute muna kita ha. Para may nag-aaway dyan eh. Okay, so resume tayo na. Saan tayo tapos? So unit vector. So any questions sa pagkuha ng unit vector? Any question? Pagyo, baka may question ka?
Wala po, sir.
Wala? Okay. So walang may question? So madali lang naman yung formula natin. So divide mo lang yung given vector by its magnitude. So doon lang iikot yan. So pwede mo siyang i-represent in decimal or fraction. Okay, so for vector field, so katulad na banggit ko kanina, vector field is basically a vector function of a position vector. So yung notation natin dito, halimbawa, given tayo ng position vector, so ang tinutukoy natin ditong position vector is kapag halimbawa, given ako ng certain point, so di ba kanina, diniscuss natin position vector. Meron din tayong distance vector na. Then yung unit vector. So sulat ko lang yung mga different vector na discuss natin. Then unit vector. So yung position vector, ginamit natin dito isang point. Alam mo, given ka ng point P na X, Y, and Z. So pwede mo na agad kunin yung position vector. So yung X, Y, Z will be the coefficients of AX, AY, and AZ. Then i-add mo lang sila. So yung distance vector, ima-minus mo kung kailangan mo ng dalawang points. So P and halimbawa Q. Then si Q is X1, Y1, Z1. So para makuha si distance vector, kailangan meron kang dalawang points. For unit vector, isang point lang yung kailangan mo. Then gagamitan mo lang ng formula na ito. Kung vector P, so i-divide mo lang yung vector P ng magnitude niya para makuha si unit vector. For vector field, so this is just a vector function of a position vector. So for example, given tayo ng position vector R, the vector field is represented by this notation, G of R. Okay? Which is yung G will be your vector field and yung R is position vector. So example, for a scalar field naman, the notation is T as a function of R. For example, yeah, so this example is a vector field G. Okay, so vector field G and using position vector R. Okay, so ito yung position vector R which is given by this equation, XAX plus YAY plus ZAZ. And it is represented, ito ngayon yung magiging vector field. Okay, so this is your vector field. Okay? So another example. So halimbawa ito. Solve for G, RP, and unit vector in the direction of vector field G at point P. Oops, parang kulang given. Ayan, sorry. So, meron binigay na RP. So, using this RP, so this is your position vector. Okay, so itong position vector, pwede mong makuha dito yung point P. Tama? Ano yung magiging point P natin? Ano yung magiging point P? Sino yan?
1,
Sino yung nag-raise na? Yeah, Orehenes.
1,
Ano? 1,
2, negative 3.
negative 3. Okay, so that will be your point P. So, ang pinapahanap sa atin is vector G using position vector RP. Which is, kanina may binigay na tayo vector G. Ito daw yung vector G natin. So, isulat lang natin dito na. So, 2x over 1 plus y squared ax plus y plus 1 na doble yung L. y plus 1 ay plus 5x minus z. 5x minus z squared ac. So this will be your vector field G. Okay? Pero kung with respect to RP, using position RP, so gagamitin mo ngayon yung values ng point P, isa-substitute mo dun sa value ng x, y, and z dun sa bawat coefficient. So for this particular vector field, kasi ang tinanong niya is solve for GRP in the direction of vector G at point P. So 2, ano yung value ng x? So 1. Divide by 1 plus y squared. So 2 squared ax plus, so 2 plus 1 ay plus 5 times 1 minus negative 3 squared az. So solving for this, anong value natin dito? Ano to?
2 over 5 po.
2 over 5 ax. Ito isa. 3 ay. Then tong az.
Negative 4.
Negative 4. So negative 4. Tama ba?
Tama po.
Negative 4 az. So this will be your G RP. Okay? So dito sa kanina, sir, bakit dito may mga xy ka pa? Kasi ang coefficient ng R natin dito is x, y, and z. Kaya nanatili lang silang x, y, then y, x, z. Pero once na yung nagkaroon na ng specific value yung mga coefficient, hindi na lang siya basta variable, papaltan mo na yun doon. So dito, 1, 2, and negative 3 na. So papaltan mo na ngayon yung mga x, y, z dun sa vector field equation. Kaya nakuha natin sagot for vector GRP or vector field G is 2 over 5 ax plus 3 ay minus 4 az or minus 4 az. So, paano si unit vector? So, isa pang pinapahanap kasi sa atin is si AG. Okay, so ito yung representation natin AG. Unit vector in the direction of vector field G. So, this will now be equal to 2 over 5 ax plus 3 ay minus 4 az divide by magnitude, which is, ang formula natin ng magnitude is 2 over 5 squared plus 3 squared plus negative 4 squared. So, ano magiging final answer for AG? Unit vector. Solve. Ano sagot natin? Sa AX muna. So, kunin nyo muna yung magnitude, and then divide nyo yung bawat coefficient ng magnitude. Anong sagot?
Ayun po, sir.
Sino yan? May nagsasolve ba? Wala.
Yung baba lang po ba, sir? Or yung buo na?
Sige, ano muna yung nakuha magnitude? Magnitude muna ni G. So, magnitude ni G.
5.016.
5.016. Okay, so yung 5.016, divide natin yung 2 over 5. So, anong sagot? Sa AX. .2/5 divided by 5.016. 3 decimal na lang.
$4.984 po.
Ilan?
4.984 po.
Parang malayo yun So, 2 over 5 divide by 5.016.
0.079.
0.079. So AX next plus ano to? Plus ano to? 3 divided by 5.016. 0.598
598.
AY. And then minus 4 divided by 5.016.
Negative 0.797.
0.797 AZ. So this will be your unit vector in the direction of vector field G. Okay, so yun yung magiging dalawang sagot mo. So itong una, yan yung vector field G using position vector RP. And then yung pangalawang naka-box or naka-rectangle is yung unit vector in the direction of vector field G. Question? Any question? No oras na. Okay, so meron ba tayong 15 minutes? So walang question dito? Madali lang ba? Wala kayong question, ha? Pwede na tayong mag-quiz siguro next meeting. Walang question eh. So ibig sabihin, na-gets?
Sir,
Yes.
pwede pong pa-audit lang po nung steps para pong guide.
Alin part? Dito sa example, itong last example.
Opo, steps lang po.
Okay, sige. Sobrahin muna natin. So, pag pinahanap sa iyo yung solve for vector field G, tapos may nasa loob ng parenthesis RP. So, nire-represent yung nasa loob ng parenthesis will be yung position vector. Okay, which is given sa atin dito, AX plus 2AY minus 3AZ. So, hindi, yung isang given pa dyan, yung nandito sa kabilang slide. So, naputo lang na. Dito pa yung isang given eh. So, sulat ko dito So, G is 2x 1 plus y squared ax plus y plus 1 ay plus 5x minus z squared az. So, ito pa yung isang given. Yung vector field daw natin is given by this equation. So, pag pinahanap sa atin yung vector field G with respect to unit or with respect to position vector RP, papalitan lang natin lahat ng x, y, and z dito sa equation nung point nagre-represent dito sa vector ito. So, kaya kailangan, ang first step mo, kunin mo yung points na nagre-represent dito sa position vector, which is, kunin mo yung points. So, ano yun? So, 1, 2, and negative 3. So, once na nakuha mo na yung mga points, i-substitute mo na siya dito. Okay, so i-substitute mo dun sa mga variable 2x, y, then sa z. So, makukuha mo na yung g will be equal to 2 times 1 over 1 plus 2 squared ax plus 2 plus 1, kasi y plus 1 tayo dito, ay plus 5 times 1 minus z squared. So, negative 3 squared az. Okay, and then solve mo yan. Nakukuha natin dyan will be 2 over 5 ax plus 3 ay plus, ano nga ito? Negative 4 to, ano? Negative 4 az. So, this will be your answer na for GRP. Okay? Nakuha? Then for the unit vector, ang unit vector natin is A, letter A yun. And then yung subscript niya is kung anong saan direction ba siya, which is according dito, in the direction of vector field G. So yung subscript niya will be G. So yun yung pinapahanap sa atin, which is, ang formula is yung vector G divide by magnitude niya. Okay, so yun yung ginawa natin kanina. So ilagay mo 2 over 5 ax plus 3ay minus 4az divide by square root. So ito yung formula ng magnitude, no? 2 over 5 squared plus 3 squared plus negative 4 squared. So makukuha mo na ngayon yung unit vector. Okay, nakuha. So basically, ang first step, kunin mo yung points kung hindi given. So once na nakuha mo na to, i-substitute mo na lang dun sa equation ng vector field. Then kunin mo yung main equation ng vector field at that particular vector. Pag pinahanap yung unit vector, so gamitan mo lang ng formula. Okay, question. Any question pa? Okay, so proceed tayo dito sa dot or scalar product. So the dot product, so ito na yung kapag involved na yung dalawang vector. So meron kasi tayong two product. Okay, so yung naging result ng multiplication ng two vector. So yung una is yung dot product or scalar product. So the dot product of two vectors, halimbawa si vector A and si vector B, in a n-dimensional space is defined as. Okay, so ito yung formula. So summation from 1 to n of the product of A sub I and B sub I, which is equal to A1 B1 plus A2 B2 hanggang AN BN. So kung 3-dimensional lang tayo, so hanggang ano lang, kasi ito applicable to up to n-dimensional space, so kahit up to 100D. Okay, so pero di ba limited, sabi ko kanina, focus lang natin is 2D and 3D. Pero pwede yung gamitin in 100 or more than 100 dimensional space. So usually, pag ganyan na kadami yung dimension, involved na dyan sa, sa images na. Okay, so usually, kapag nagkakaroon tayo ng image processing, okay, so ginagamitan na natin yung mas more than 3 dimension. Pag gusto natin i-enhance yung certain image, or i-process, so dyan na involve yung math na more than 3 dimension. Pero since sa IMAG, hanggang 3 dimension lang tayo, so pagkuha ng dot product is hanggang, ano lang, so basically, ang mangyayari dyan, kung meron kang 2 vector AB, tapos yung vector A is given by these points, x1, y1, and z1, then vector B is x2, y2, and z2. Pag kukunin mo yung dot product using this formula, so yung dot product ni A and B, okay, so yung dot product is represented by this dot. Okay, so pag ganyan nakita nyo, dot product yan. So equal lang yan sa x1, x2 plus y1, y2 plus z1, z2. Okay? So, yun na yun. Summation lang naman. Or, pwede rin gawin mo, another formula, kunin mo yung magnitude ni A, kunin mo yung magnitude ni B, and then i-multiply mo sila sa isa't isa. Then, multiply mo yung result dun sa cosine ng angle between the two vectors. Okay, so ulitin ko ha. Meron kang two way ng pagkuha ng dot product ng two vectors. So, una, using this formula. Okay? So, kung 3 dimension, so A1, B1 plus A2, B2 plus A3, B3. Kung ang A1 natin is X1, ang B1 is X2, so plus ito is Y1, Y2 plus Z1, Z2. Okay? So, yung isang way. Or, pwedeng gawin mo, magnitude ni A times magnitude ni B times cosine theta, which is yung theta na to is angle between the two vectors. So, if given yung angle between the two vectors, mas madali ito yung gamitin ng formula. Kunin mo lang yung magnitude ni A, magnitude ni B, multiply mo, tapos multiply mo sa cosine ng angle between the two. Okay, so yun yung two-way na pagkuha ng dot product or scalar product. Okay, so meron tayong three properties for that product. So first is the commutative property. So ibig sabihin, in that product, so A dot B is also equal to B dot A. So kahit magkabaliktad, okay lang. So same with yung kanina, no, vector addition. Another one is the distributive over vector addition. So if meron tayong vector A, then na-factor out siya, nasa labas ng parenthesis sa addition ni vector B and C, so pwede mo distribute yun. Okay, so that product, instead na i-add mo muna si vector B and C, so pwede yung gawin mo, distribute mo si A, pati yung that product operation. And then yung last is, if yung dalawang vector is at 90 degrees with each other. So we call that orthogonal vectors. So remember nyo to ha. If meron kang dalawang vector and perpendicular sila sa isa't isa. Okay, so perpendicular sa isa't isa si dalawang vector. So ibig sabihin, ang angle between the two is 90 degrees. So yung dot product nila will be 0. So kahit hindi mo na yan isolve. Okay, so halimbawa ito si vector A, ito si vector B, at 90 degrees sila sa isa't isa. So yung dot product ni A and B will always be 0 kahit hindi mo na isolve. Kasi, dahil dito, no? Diba ang cosine 90 is 0. So magzi-0 lang din. So we call that orthogonal vectors. So kung natatandaan nyo pa, di ba sa differential equation, no, meron tayong orthogonal trajectory. Yung orthogonal, it means they are at 90 degrees with each other. Okay, so orthogonal vectors are two vectors na yung angle between these two is 90 degrees. And yung dot product nila will always be 0. Question. Okay, so malinaw yun ha. Yan yung three properties ng dot or scalar product. Oras na. Okay, siguro hanggang dyan na lang muna siguro tayo and then next meeting, discuss natin yung magbigay din ako ng example. So para matapos natin hanggang dito sa cross product. Okay, so bigay ko muna yung formula sa inyo. Any questions sa discussion for today? Question? Or gusto i-clarify? Any question? Wala? Borromeo, baka may question ka?
Wala po, sir.
Wala naman. Okay, so if wala ng question, so next na lang ulit tayo. Next week tayo ulit mag-meet kasi holiday sa Thursday. So see you na lang ulit next week. So pwede na kayo mag-leave if wala ng question.